Hello. I'm going to show you something called Cantors diagonal argument. I don't know whether there's an E there or not. Probably not. George Cantor did this in 1891. So over here, these are all the fractions. I've begun to list every fraction. Of course you can't list them all, but you can list as many as you like if you've got time. And this is a way of listing them in order, so that you know you've got them all. So you get a half, and then can you see each row is halves, thirds, quarters, fifths, sixths, sevenths, eighths. Some of them are repeated, like this 2/4 is the same as a half, but I've listed them all so that it's absolutely clear that I am listing all of them. Well, begun to. And then over here I'm listing them down here. I'm missing out the ones that are repeated. So we've got a half, a third, 2/3, a quarter, 3/4, a fifth, and then I stop. But I could go on. And I've written out the beginning of their decimal equivalents. So really there's a decimal point in front of this 5 and in front of this 3, but I've not actually written those decimal points in. So a quarter is 0.250000, and so forth. What I'm going to do now is I'm going to construct a number that can never be in this list, no matter how many of them you'd make, no matter how many you actually list, millions of them. I'm going to list a number. I'm going to write a number down here that can't be in that list. And the way I'm going to do it, there are different ways of doing it, but the way I'm going to do it is I'm going to do what Cantor did. You look at the diagonal numbers. Right. All these numbers on the diagonal. Right. And then I'm going to look at each one, and down here I'm going to add 1 to whatever number is in the box. So that would be a 6, then a 4, then a 6, then a 7, then a 1, and then there's a whole load of 1s to there, and then a 7, and then a 4, is that right? Yeah. 4, 8, 2, and then whatever they are. carry on and on, all the way down. Carry on and on and on. And this is actually a decimal with the point there. Have I done that right? 5, 3, 7, 1, 1, 1, 1, 1, 7, 4, 8, 2. Good. And this number is different from any up here. So by the time you enter this number here, it's different. Oh, that's not right, is it? That should be a 3. Well, this number is different from all the numbers, all the diagonal. And that means that this number is different from each one. So if I list every number, this number can't be the same as any of them, because I've altered. This is an alteration of every one. And I showed your dad this, I showed David this, this kind of thing a while back, and he said, oh no, this is just a number that you haven't got to yet. And I didn't know how to answer him. And what I'll say now is, okay, if this is a number that I haven't got to yet, then let's write it in the list. But if we do that, when I do get to it, I'm going to change it. And this number will then be different from it. So whichever number you claim this is the same as some other number that you've not got to yet, it's actually going to be different, because when I get to that number, I'm going to change it to make this one. Now this is a way that George Cantor showed that there are more numbers than just the fractions. He proved this way that the number system must be bigger than the list of fractions. How about that?